A single card is drawn at random from an ordinary deck of cards. Find the probability that it is either an ace or a black card. All right, so we might have to go back to our deck of cards. We're looking for an ace or a black card. So first off, what's the probability of an ace? How many aces are there? 4 out of a total 52 cards. What's the probability of getting a black card? How many black cards are there? 26 out of the 52. Do they have an overlap? So where or how many of them overlap? 2. Because there's 2 cards that are aces that are also black. So we need to subtract the 2 out of 52. And that's going to leave me with 28 out of 52. And let's turn that into a probability. So 0.53, I should round to 54?
It would round up to 54.
All right. So then, again, we're going to be picking, and we want those sentences. The probability of getting an ace or a black card is 54%. Questions on it? Oh. Right. I subtracted 2 because I included the 2 black aces in my count for aces. But then when we went and we said, how many black cards do we have? We went and we said there was 13 black cards in each, or there's 13 cards in each soup. We have 2 of them that are black, and we added those together and got the full 26, but we double counted those black aces. So we need to subtract out 1 of the times that we counted those aces. Other questions? All right, let's take a look at our hospital data. So in a hospital unit, there are 8 nurses and 5 physicians. 7 nurses and 3 physicians are females. If a person is selected, find the probability that the subject is a nurse or a male. So we've got a lot of information going on, and I want to kind of collect it if I can. So I'm going to make a little table to help myself. We've got our staff, and our staff is either a nurse or they're a physician. And then they're either males or females. And let's try to figure out what they told us. So we know there's a total of 8 nurses. We're going to make our total column here at the end. So we have a total of 8 nurses, and we have a total of 5 physicians. 3 of the physicians are females. So, I skipped part of it, but that's okay. So 3 of these physicians are females, so I'll put that in the spot for the females and physicians. 7 of the nurses are also female, so we'll put 7 of them there. Now, do I know how many of the nurses are males? How many? And how many of the physicians are males? And then I'm going to create a total column down here as well and say I have a total of 10 females and 3 males. And all together, we have 13. So the total for all the sample goes in this bottom space. If we want to call it our N, that's our overall sample size. And it just kind of helps me see the groups that I've got here as far as this data is concerned. So then I want to actually find the probability that a subject is a nurse or male. So this is still my OR probability. So I'm going to say probability they are a nurse or male. So first off, what's the probability that they are a nurse? How many of them are nurses? 8 out of my total 13. Then, what's the probability that they're male? How many total males do I have? 3 out of my 13. Have I double counted anybody? How many? One of them. I double counted this column right here with the one male that's also a nurse. So we'll subtract that out. And what are we going to get? 10 out of 13, which gives me 0.177. So that means the probability of selecting a nurse or a male is 77%. It can just be kind of nice to organize our data a little bit when we have a lot of different information in there. Questions on that? All right. On New Year's Eve, the probability of a person driving while intoxicated is 0.32. The probability of a person having a driving accident is 0.09. The probability of having an accident or driving accident while intoxicated is 0.06. What is the probability of a person driving while intoxicated or having a driving accident? So they gave me a lot of information, and that is always my first step is to kind of go through, read the question, and then let's assess what we have after. So let's kind of break down each piece. I know that the probability that a person drives while intoxicated. So we have the probability, we'll just say probability of I, that they're intoxicated, is equal to this 0.032. Then I know the probability of a person having an accident, a driving accident, is 0.09. So let's say the probability of A for our accident is 0.09. I have one last piece of information, and I want to know what it is. So the probability of having an accident while intoxicated. So now they're both things at the same time, and that's like my and. They are intoxicated and had an accident is 0.06. And then if I come down here, they asked me about an or. They said the probability of a person driving while intoxicated or having an accident. Do we have the pieces of information we need for that or probability? Yes. So the probability of being intoxicated or an accident, well, that's the probability of being intoxicated, so 0.032, plus the probability of an accident, minus their overlap, so minus the 0.06. So what's that going to give me? .35. So that tells me the probability of driving while intoxicated or having a driving accident is 35%.